All right, so today, where are we? Right here, the 25th. A continuation of Friday. We're not going to do anything new. We'll just answer questions from Friday's worksheet and then do a few together from today's worksheet. So, looking at Friday's worksheet, what questions do you guys have?
Number 2, part C.
2C. All right, well, let's just do all of 2 because we might need to get to C. Maybe not. So looking at number 2, get my face out of the way there. The graph of f prime, this is the graph of f prime, consists of a semicircle and 2 line segments. Determine the values of x on the open interval at which f has a relative maximum. Okay, well, even without this picture or this problem at all, I know that f has a relative maximum when f prime changes. Maximum would be positive to negative. Oh, well, that's helpful because I have a graph of f prime. So that happens at x equals positive to negative at x equals 2. And that's it. So at x equals 2. So it's a good concept question. Not a whole lot to compute. As long as you understand what's being asked, it doesn't take long to get the answer. Determine the values of x on the open interval at which f has a point of inflection. Justify your answer. Okay, well, f has a POI when f double prime changes signs. All right, so for the second derivative, we don't care about plus to minus, minus to plus, as long as it's changing signs. F double prime, though, I don't have any information about f double prime, but I know that f double prime is the slope of f prime. So I want to know when the slope of f prime changes signs. Or when f prime goes from increasing to decreasing or vice versa. So you can phrase it either way. So when f prime changes from increasing to decreasing, that would be at x equals 0. Not at x equals 2. Something weird's going on at x equals 2, but it stays decreasing. So that's not a point of inflection. At x equals 4, we change from decreasing to increasing. F prime changes decreasing to increasing. So f double prime changes signs, which means there's a point of inflection. All right, part C. If f of 0 equals 3, then determine f. All right, well, it's asking me questions about f, but it's given me f prime. Well, I know that if I integrate f prime, I get information about f. So my main concern is what x values do I want to use for my integration? 0 and 4, because those are the x values that I have. So I'll go from 0 to 4, which means I'll have f of 4 minus f of 0. And then this I can get from the area under the curve, or area under f prime, from 0 to 4. So be careful. I've got more information than I need here. So from 0 to 4, that's another one of those quarter circles. Pi r squared over 4. If r is 2, that gets me pi. And then to 4, 2 times 2 is 4, divided by 2 is 2. What do I need to be careful about there? It's below, so I'm going to label it negative 2. Everybody knows that when I say, what do I need to remember? Will you remember it without me saying, what do you need to remember? I hope so. So that means the area from 0 to 4 is pi minus 2, and that equals f of 4 minus f of 0, but f of 0 is 3. That's not quite a safe stop, right, because I have to know what f of 4 is. So I'll move the 3 over. So pi plus 1 is f of 4. What else would you like to see from that worksheet?
I was kind of confused on how to get the numbers in the table, like for 1C.
Okay. So 1C, the numbers in the table. Okay, so this is the graph of f. Capital F is the integral from -1 to x. So the area under this graph. Complete the following table. So maybe let's go one piece at a time here. So capital F of -1, because that's what needs to go right in this spot. I look back up at how f is defined. It's defined as the integral from -1 to whatever this value is under that curve. Well, that's an easy one, because -1 to 1 would just be 0. For 0, it would be the integral from -1 to 0 under f. So that would be this area, which I'm not going to do a trapezoid. I'm just going to count the boxes on this one. One box plus half a box is 1.5. Good? Keep going?
Yes, I got it. Thank
Okay. -1 to 1 and so on. 2.5. So just make sure you add up 1.5 and 2.5 would be 4. And so on. And then part D is, does that sort of match with what you figured out in part B? So kind of putting, part B is kind of a calculus way. Part C is, I guess, still calculus, but two different ways to find a max or a min, and then see if those two things agree with each other. Not worried about 6 so much because we've done a bunch of those like that. But 4 or 5?
Can you do 5, please?
Number 5. What? F of x, capital F, equal this weird thing. Oh, chain rule is probably coming up here with that 3x in there, so I need to be careful with that. Write the equation of the line tangent to f at x equals 3. So I need slope and a point. So slope of f, which means f prime, at 3. And I need the point, which would be 3 comma whatever f of 3 is. Okay, so I guess I could put that in there. I need f of 3 and I need f prime of 3. I don't know which one's easier. Let's do f of 3 first. So f of 3 is the integral from 0 to 3 times 3 of t to the 1/2 dt. I switched it because I don't want to integrate a square root. I want to integrate a power. So I switched it to t to the 1/2. So the integral from 0 to 9 of t to the 1/2. So this one is, we've done this before. It's area under the curve, but I don't want to do area under the curve because I don't know what the curve, well, I know what the curve looks like, but I don't know any geometry that would help me with the area under that curve. Instead, we'll have to do the antiderivative, increase the power by 1, divide by the new power, from 0 to 9. So that would be 2/3 times 9 to the 3/2. I guess minus 2/3 times 0 to the 3/2, but that's going to be 0. The danger of 0 at the bottom, if we give you too many of those, then you forget to include it at all because you think it always just goes away. So showing it, even though if you didn't show it, you'd still be right. So 2/3 of, let's see, 9 to the 3/2. That'd be the square root of 9 is 3. 3 cubed is 27. 2/3 of 27 is 18. So the point is 3/18. But the slope, f prime, so I need to take the derivative of this guy. But the derivative and the antiderivative cancel each other out. So it's going to be the square root of 3x, because I put 3x in there, but then times 3, so the chain rule. So f prime of 3, I'm going to have 3's everywhere. The square root of 3 times 3 times 3. This 3 was the input 3. The other 3's were part of the formula. Square root of 9 is 3 times 3 is 9. So the slope of f is 9. The point is 3/18. This should be easy now. Y minus 18 equals 9 times x minus 3. Ugh, there's a lot in that problem. All sorts of stuff in that problem. Four or 7? Are we okay? You just want to jump to the next worksheet and do some of it together?